Hello, 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 my fellow mathletes. It's Root Beer here, and we're going to be starting another Manitoba Math Contest. This time it will be the 2013 paper. So we have our wonderful sponsors here. We got 2-hour time limit, wonderful things to note. It's intended for students in grade 12, and this is all the sort of thing that you should be reading. The instructions quite nicely in bold. They do have calculators not permitted, but I'll let you guys read through that and appreciate the wonderful sponsors out there promoting math contests. We're just going to jump right into it with question number 1 in this video. So 1A. The angles of a triangle are in the ratio 2 to 3 to 4. Find the largest of the 3 angles. Okay, now this would be an interesting question if it was sides. But no, it's just angles, so let's really quickly draw a picture of a triangle, label some angles, and the nice thing about the angles in a triangle, at least on a flat surface, which is where almost all math contest geometry takes place, the angles all add up to 180 degrees. So because they're in the ratio 2 to 3 to 4, we know there exists a number k, so that one of the angles is 2k, another one is 3k, and then the third one is 4k. Okay. The issue with figuring out the angles now becomes, can I figure out this k value? Well, it's angles in a triangle, so we know 180 degrees is 2k plus 3k plus 4k, but that's all 9k. Dividing by 9 on both sides, which is something we can do without a calculator. If you need to, divide the old way. But we get k is 20 degrees. Okay, but they didn't ask us what k is. They asked us for the largest angle. And you can either work out each of the 3 angles and say, oh, gee, okay, 80 degrees is going to be the biggest one. Or you just say, well, the biggest one's going to have to be 4 times k. 4 is the biggest of these 3 numbers. So 4k is just going to be 4 times 20 degrees, which is 80 degrees. And that's the biggest angle. Okay. So that's 1A. We still have 1B to do. The sides of a triangle are integers. It has positive area, and its perimeter is 12. How many such triangles exist? So the statement positive area is a little weird. I think what they're going for is to not have degenerate triangles. So you'll never ever have negative area, which incidentally, historically, is why the Greek mathematicians didn't really talk about negative numbers, because they assigned numbers were only things that had area. It's also sort of the reason why they didn't talk about 0 as a number. But in theory, if I had 3 sticks, I could put them together to form a triangle. And if that's your definition of a triangle, is just 3 sticks connected to each other, you could have just sort of a very flat line with 2 sticks flat against a third stick. And in some weird definitions, that counts as a triangle, but we call it degenerate. It's not really useful, it's just a line. So that's what they're trying to avoid here. A flat stick with 2 other sticks next to it has 0 area, because it's just a line. So we want positive area. Now, how can we actually tell whether or not we get something like that? Well, we use what's called the triangle inequality. It's a very useful inequality, especially if you go on to do any sort of proof-based math in university. So you get a triangle with positive area if your chosen sides A, B, and C satisfy these 3 inequalities. And the last one is A plus C greater than B. Now, in practice, if you know the longest side, you really just need A plus B greater than... If C is the longest side, you just need A plus B is greater than C. Everything else comes automatically from C being the longest side, but these are the triangle inequalities. Okay? Notice that this fails if we have 2 sticks against a third stick. I mean, technically, you get A, B, C. The length of C is A plus B, but this is flat. This has 0 area. So these are the things that we want to have happen. Now, we are told the perimeter is 12. How do we calculate perimeter on a triangle? Why, it's A plus B plus C. I'm going to suppose that C is the biggest one. I'm not going to say it has to be strictly greater than B, but I'm going to suppose this is the case. And obviously our sides have to be at least 1. Sides of the triangle are integers, yeah, but you can't have a 0 side length or a negative side length. Okay. So what can we have? Well, we need A plus B to be greater than C. Well, A plus B is 12C, so 12 minus C. So 12 minus C has to be greater than C. This has to be true. And if this is true, then automatically, if C is the largest one, you don't need to worry about these other ones. Satisfied automatically. So that tells me 12 has to be greater than 2C. So C is at most 5. Okay, C can't be 6. Because then, you could have 6, 4, and 2, but that's going to be one of those flat triangles. So C can be at most 5. Fantastic. That tells me A plus B is at least 7. I think what we should probably do is work out some cases. So C could be 5, sure. And then A plus B would be equal to 7. Now A is less than or equal to B. So that tells me 2B is greater than or equal to 7. It's greater than or equal to 2A, because this is in between the two of them. But this is less than or equal to 2C, which is 10. So 2B has to be an integer less than or equal to 10 that is even. So 2B is either 10 or 8. And so B is then either 5 or 4. And these tell me, because A plus B is 7, A is 2 or 3. So we get two triangles in this case. We get a 5, a 5, and a 2. And a 5, 4, and a 3, which is a nice little right angle triangle. Okay. So what else could we have? Well, we could have C be 4. If that's the case, then A plus B is going to have to be 12 minus 4, which is 8. Okay. Now, once again, we can see that 8 is 2C, which has to be greater than or equal to 2B, which has to be greater than or equal to 8, because that's A plus B, which has to be greater than or equal to 2A. But 8 mean the 8s on either side mean that 2B is going to have to be 8. So B is going to be 4, and that forces A to be 4 as well. We get just one other triangle here. And we could keep going. We'll just really quickly up here talk about C equals 3 or less. You're going to have A plus B is, so if C is less than or equal to 3, A plus B is greater than or equal to 9. And that forces 2B to be greater than or equal to 9. But 2C is less than or equal to 6. Something's gone horribly wrong. Because then you have 6 greater than or equal to 2C, greater than or equal to 2B. Because remember our original assumption. C is greater than or equal to B. But of course 6 is not bigger than or equal to 9. So you're not going to have anything else there. So therefore we have 3 triangles. And I did happen to write them all out. 2, 5, 5, 3, 4, 5, 4, 4, 5, or 4, 4, 4. But they just asked for how many such triangles? 3 triangles. So you do need to justify things, but you probably didn't need to go into that big a detail for justification. I mean, it is 1B after all. So in the next video, we're going to take a look at question number 2, both A and B parts, and I will see you guys there.